Hello everyone. Today's learning goal is to review scientific notation and SI units. I want to talk about this number 6,000,000,000,000,000,000,000,000,000,000 kilograms. This is the mass of the Earth. Big number, bigger than the ones that we're usually dealing with in our everyday lives. Let's read it a different way. This is really no better. 6 million kilograms. It's not useful to communicate numbers in this way. If you needed to say that number back to me, probably you would mess that up. If I tried to say that number back to you from memory, I would mess that up. So we use something called scientific notation to more effectively communicate large numbers or even small numbers. So let's take a look at some examples of large numbers and how we can write them using powers of 10 in scientific notation. The number 100 is 10 times 10. So we can write that as 10 to the power of 2, which means we multiply 10 by itself twice. 10 times 10. The number 1,000 can be written as 10 times 10 times 10, or 10 to the power of 3. So we're multiplying by 10 3 times. You go ahead and try to write the number 100,000 using powers of 10. Write this in your notebook. Pause the video now. Okay, hopefully you gave that a try. Let's take a look at the solution. So 100,000 can be written as 10 times 10 times 10 times 10 times 10, or 10 to the power of 5, meaning we multiplied by 10 5 times. Let's look at some more complicated examples. So for example, the number 200 can be written as 2 times 100, or 2 times 10 times 10, which is 2 times 10 to the power of 2, meaning we have to multiply the number 2 by 10 twice. Okay, the number 4,500, this one's a little trickier. So this is going to be our strategy. We're going to write the number 4, so this is the leftmost digit. Then we're going to write a decimal place after the 4, and then we'll write the trailing digits. In this case, just a 5, because those trailing zeros, they're implied, they don't really matter. So we write the number 4.5. And 4.5 we need to multiply by 10 3 times in order to get 4,500 as our answer. So we're going to do 4.5 times 10 times 10 times 10, or 4.5 times 10 to the power of 3. So this is scientific notation, 4.5 times 10 to the power of 3. It's equivalent to writing 4,500. And it becomes really useful when we deal with extremely large numbers. Take a look at this one over here, 1,200,000. You go ahead and try that, convert it into scientific notation. Pause the video now. Okay, hopefully you give it a try. Let's check your solution. 1,200,000. We're going to write the leftmost digit, 1, followed by a decimal point, followed by whatever numbers are after. So in this case, just a 2, because the remaining zeros are implied. We don't really need to write them. 1.2 is the same as 1.2000. So we'll write 1.2 times 10 times 10 times 10 times 10 times 10 times 10. So that's 1.2 multiplied by 10 6 times. So this number is 1.2 times 10 to the 6. We have it in scientific notation now. Okay, now I want you to try the example, the Earth example. Write the mass of the Earth using scientific notation. Pause the video now. Okay, let's take a look at the solution. So we're going to write the leftmost digit, number 6, followed by a decimal point, followed by the remaining digits. So those are all zeros. And then we have to multiply times 10, 24 times. Let's double check that this is really true. So there's a 6, and now we're going to have to multiply by 10. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 kilograms. So we multiply by 10 24 times to obtain this number, the mass of the Earth. 6 times 10 to the 24 kilograms is much easier to say and much easier to remember than 6000. I'm not going to say it again. You get the picture. It's horrendous having to say all those zeros. So this is why we use scientific notation. You write this down. It takes up less space on your page. People know what you're talking about. It takes a little bit getting used to, but eventually you get used to it, and it makes communication much easier. So let's do the same thing, but now for small numbers. So let's take a look here. 0.01. So this is 1/100th. So we would need to write the leftmost non-zero digit. That's the number 1. And now we're going to divide by 10 twice in order to get 0.01. So this is the same as saying 1 times 10 to the negative 2, or just 10 to the negative 2. For 1,000th, we've got 1, 2, 3 decimal places that we would need to move the decimal place over. So we've got to divide by 10 3 times. We're going to do 1 divided by 10 divided by 10 divided by 10. That's equal to 0.001, or 10 to the power of negative 3. You go ahead and try this one. So this one is 1/1,000,000th. Go ahead and convert it into scientific notation. Pause the video now. Okay, let's check your work. So let's count how many digits we would need to move the decimal place over. 1, 2, 3, 4, 5, 6. So we write the leftmost non-zero digit, that's the number 1. And now we have to divide by 10 6 times. 1, 2, 3, 4, 5, 6. So 1 divided by 10 6 times, or 10 to the power of negative 6. Negative exponent means divide by 10. Positive exponent means multiply by 10. Try this one. What is the mass of hydrogen? Convert it into scientific notation. So go ahead and turn this ridiculously small number into scientific notation. Pause the video now. Okay, let's review the work. We're going to write the leftmost non-zero digit. That's the number 2. If there were more digits to the right of this number, we would put a decimal point and then the remaining digits. In this case, we just have a 2, so we're going to write the number 2. And now we have to figure out how many times we would need to divide the number 2 by 10 in order to obtain this number. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. We need to divide the number 2 by 10 27 times. So we're going to write 2 times 10 to the negative 27 kilograms. Okay, let's review something a little bit more advanced. So you may remember this from your math class. How do you multiply or divide numbers that have the same base but different exponents, or the same exponent, doesn't really matter, but they have the same base. How do we divide these? So the rule for dividing numbers with the same base that have exponents on them is to subtract the exponents. If you're multiplying two numbers with the same base, you will add the exponents. So in this case, let's try these. 10 to the 9 divided by 10 to the second power would be 9 minus 2 is 7. It would be 10 to the power of 7. You go ahead and try this one. 10 to the power of 10 times 10 to the power of 2. Remember, they're multiplying, so we're going to add the exponents. Give it a try. Pause the video now. Okay, take a look. Here are the solutions. 10 to the power of 7. We have to subtract 9 and 2 to get 7 because we're dividing. When we're multiplying, we have to add, so 10 plus 2 is 12. So we add the exponents. 10 plus 2, this is 12. This is a general rule. So instead of having actual numbers, we just wrote m and n as our variables, and then we know, you may want to write this in your notebook. Pause the video, write it in the notebook so you remember. Okay, moving on. Here's the tough one. Give this a try. Take the mass of the Earth and divide it by the mass of the hydrogen atom. Mass of the Earth divided by the mass of the hydrogen atom. Use the rules from before. Try it. Let me know how it goes. Pause the video. Okay, hopefully you gave this a try. This one's a tough one. Let's take a look at the solution. So we're dividing two numbers with the same base. Let's split this up into two math problems, actually. So the 6 and the 2, these numbers in front, these coefficients, we're going to divide those separately. 6 divided by 2 is 3. 6 divided by 2 is 3, so our coefficient is going to be 3. And now let's deal with the powers of 10. So we've got 10 to the 24 divided by 10 to the negative 27. 10 to the 24 divided by 10 to the negative 27. The rule is to subtract the exponents because we're dividing. So we're going to subtract 24 and negative 27. That's 24 minus negative 27. When you subtract the negative, that's the same thing as adding. So we're going to say 24 plus 27, which is 51. So we've got 3 as our coefficient times 10 to the 51 power. That's a lot of hydrogen atoms that you could put together and make an equivalently a body of equivalent mass of the Earth. 10 to the 51 atoms times 3. Okay, let's go on to the metric system, so SI units. Let's talk about the base units. The base units of length in science, we use meters. For mass, we use kilograms. For time, we use seconds. And then there's also prefixes that we put in front of these things. So commonly we use these ones. There's additional ones, but these are the most common ones that we'll be dealing with in this class. Giga means 10 to the 9, and it's represented by a capital letter G. Mega is 10 to the 6, and it's represented by a capital letter M. Kilo is 10 to the 3rd, it's represented by a lowercase k. Milli is 10 to the minus 3. That one is represented by a lowercase m. Micro is 10 to the minus 6. This one's represented by the Greek letter mu, M-U. And this is, it looks like a U with a little tail on it. Look, it's got a tail. 10 to the power of negative 9, that's nano, and we use a lowercase n for that one. So let's see how we would apply these. imagine you have 4,000 meters, 4 times 10 to the 3 meters. 10 to the 3 is the same thing as saying kilo, so we can abbreviate this by saying 4 kilometers, kilometers. So 4 times 10 to the 3 meters is the same thing as, I just replaced 10 to the 3 with a K, or kilo. Let's take a look. 2.5 times 10 to the minus 6 seconds. How could we write that with these metric prefixes? 10 to the minus 6 is represented by micro, this letter mu. So if I say 2.5 microseconds, that's the same thing as saying 2.5 times 10 to the minus 6 seconds. The last thing that I want to remind you guys about are the names of large numbers, because we'll be using these often, and I want to make sure everybody knows what these numbers mean. You should write this in your notebook, maybe on like the first page of your notebook. The number 1,000 is 1 with 3 zeros afterwards, so 10 to the power of 3. Million is 10 to the power of 6. Billion is 10 to the power of 9. Trillion is 10 to the power of 12. Quadrillion, 10 to the power of 15. Notice the pattern. It goes up by 3s. 3, 6, 9, 12, 15. It's easy. The next one would be quintillion, and that would be 10 to the power of, what's 3 plus 15? 18. 10 to the power 18. Great job, you guys. Just a reminder, our learning goal today was to review scientific notation in SI units. I hope you learned something today, or at least got a little bit of a review of something that you learned in the past. There's going to be an assignment for you guys to work on related to this unit. Thank you.